5.1 functions. So functions are a huge part of the algebra course. We've worked with a couple of them, and we're going to find a bunch more this year. So let's look at a couple things in general before we start. So what is a function? Well, there are different math definitions of it, and then there's some real-world definitions for it. So for example, if I had an apple and I threw it out the window and it just lay there undisturbed, then over time the apple would decay. Well, there is a function that would describe that. If I ran a factory and I had a bunch of raw materials to make plastic buttons and I threw them into a machine, then there is a function that would describe how much material I would need to make, for example, 10,000 buttons. So let's say that's 20 kilos. And then hopefully if I put in like 40 kilos, I would be able to make, double that. So from 10,000 I would get 20,000 buttons. So functions are, a function is a process in which one quantity is changed into another quantity. And that's more of a math definition than the real world. I understand that, but that's good enough for right now. So think of a function as a relationship that describes how one quantity, and we'll stick to just one at a time right now, how quantity is changed into another. Okay? So here's a more formal definition. So functions are mathematical building blocks for designing machines, predicting natural disasters, no comma there, curing diseases, understanding world economies, and for keeping airplanes in the air, for example. Functions can take input from many variables, but always give the same output unique to that function. So there's some math words here, input and output, and we'll talk about that in just a little bit. Because it's just hard to discuss functions without using some technical words, some jargon, some vocab. So, we'll learn those, right? Anyway, what do we often do with functions? Well, some of the things that we do with functions is that we often graph them. Okay, we make tables with them. We evaluate them. So evaluate means that we find a value. We compare them. So let's look at all of these. So for example, if we look at y equals 2x plus 1, hopefully you're thinking, well, that's a linear function. That's going to give me a straight line. And so we could graph it, and y equals 2x plus 1 would go through here, and then the slope says the next dot should be 1 over and 2 up. So here's a function, and here is a graph that depicts that function. I could have made a table for this function, so I could make an xy table, right? So if I plugged in 0, I would get 2 times 0 plus 1, which is 1, so the point 0, 1 would be on there. If I plugged in 1, I would get 2 times 1 plus 1, which is 2 plus 1 is 3, so the point 1, 3 would be on there, etc., etc. Sometimes you're asked to find a value, right? So if that is a function, I might say, well, what happens at x is 100? And in this case, we would just evaluate 1, right? So we do for 2 times 100 plus 1, so that's 201. And sometimes you're asked to compare. So for example, if we had another function, y equals a negative 2x plus 1, we might compare this function with that one. So for those of you that know this stuff pretty well, the red function would look a little bit like this, right? So there's something that they share, and then there's something that's different about it, okay? All right, so those are some of the things that we do in math, okay? In the real world, functions allow us to visualize relationships in terms of graphs, and that's usually easier than looking at it than a bunch of numbers, right? So here are some functions. So here's a function that describes a physical process. Okay, so here is, it's maybe hard to see, but this basically goes through the cycle of water on our Earth. Here is a function that depicts traffic patterns in a city. There is someone that looks to be enjoying a driving simulation, which is a function. And then here's something that I need to look up, which I did, and then here is a function that describes how a typhoon and what it did over a period of 48 hours. So this, what you see twirling about right now, is the result of a probably more than one function, but a bunch of functions that were used to describe a physical pattern, in this case a typhoon. Okay, so I said we do need to know a little bit of vocab here. So independent versus dependent. So first I'm just going to give you some more words, and then maybe we'll talk about what these mean. So independent is often also called the input, and dependent is often called the output. The independent, or the input, is also called the x variable, and then the output would be the y variable. Okay, since we so often graph things on an xy coordinate plane, so we're most familiar with that, right? And then we have two more terms that go with independent, dependent, input, output, x and y variable, and that would be that we associate the domain with the x variable and then the range with the y variable. So let's look at domain first and all the other stuff. So the domain tells me all the, and I'm going to use the x variable here, all the x values you are allowed to use. So the domain describes the set of numbers that you are allowed to use in your function. Okay? Then the range would be all the, and you could use any of the words here, but we'll use the word y values here, all the y values you obtain. So if you were able to plug in every single x value, then all of the y values that come out of the function would be called your range. So here's a formal definition now. A function is a mathematical relationship between two variables where every input variable has one output variable. And that is important, okay? In math, a function needs to work the same way all the time. So if I have a function where if I put as an input, let's say my input variable's value is 10, then my output variable, maybe it's 204, okay? Then the next time I put in 10, I should get 204 again. So if you plug in 10, you always get 204 out of the function. When that doesn't occur, we no longer have a function. So there are things where, you know, when you plug in 10, sometimes you'll get 204, and maybe another time you won't. And we do have mathematical ways of describing that, but then we would be talking about a relation. So let's see. Some examples of functions. So we did the linear, right? We've already seen some quadratic functions, so x squared minus 5. Basically any mathematical thing that you can think of probably has a function associated with it. So there are square root functions. We'll see those. We're going to see exponential functions. So there's an exponential function because the variable is in the exponent. And actually the next group of functions we're going to look at looks a lot like this. Those would be called hyperbolic, and they are a special group on their own. And these are all functions in x and y, okay? But you are already familiar with a whole bunch of other functions as well, even mathematical functions. Here's a relationship between the radius and the area of a circle. Here is the relationship between the area of a square and its side, and we could continue with this and do things for volume and surface area and a whole bunch of other stuff as well. So here's some notations you should know. So set notation is actually this thing here. So what we're given here is interval notation, and the questionnaire should say convert this to set notation. So this says x is greater than 0. So in set notation, you would write that this way. So 0 and then greater than 0 means you go to infinity. Okay, now the round brackets here are important, and I'll try to explain that on this one. So this statement here says m needs to be larger than 3 and less than or equal to 5. So since it says less than or equal to, I'm going to use a square bracket. Okay? So the round bracket means this. So a round bracket, which is either one of those two, means that the number is not included. So if I asked you for the first number bigger than 0 and you said 1, I would say, well, 1 is bigger than 0, but is that really the first number bigger? Because, you know, it could be a half, or it could be 0.1, or 0.01, or 0.001, or, and hopefully you're getting the idea here. So a round bracket is when we are trying to indicate that we need something bigger than, or smaller, but in this case we need something bigger than 0. I just don't know what the first number is that's bigger than 0. So we'll just say, okay, start at 0, but above 0 in this case. Whereas a square bracket means that the number is included. So the number that's either in front or behind the square bracket, the number is included. And I guess I should say is included in the solution set. So if you think back to systems equations, we had solutions. Okay, so here, 5 really is the first number that is less than or equal to 5, because it's equal to 5, and that's okay. Right, if you're given set notation like this, and you have to go to interval notation, you have to understand that this says start at a negative 4 and go to infinity. So that means that the number needs to be greater than negative 4, and then we need to check the bracket. It says it's included, so it's greater than or equal to a negative 4. Okay, and then finally we have function notation, and this sometimes confuses students. So find f of 4 given f of x is a negative 2x plus 4. Okay, well, this 4 is in the spot of the x. Well, what they're trying to tell you here is that wherever you see an x in your function, you need to replace it with a 4. So we get a negative 8 plus 4, plus 1, which is a negative 7. Okay. For some of you, it's easier to think of this as, well, that's just a y equals a negative 2x plus 4. And what they want me to do is find a y value that you get when you plug in 4 as your x value. And then we use x is 4, and we evaluate. And that's the same thing. You guys are more comfortable with this notation because that easily leads to this kind of a notation where we would say 4, negative 7. Okay, because that's the x-coordinate and that's the y-coordinate. But this is the same as saying the x equals, and this is the same as, when you use the x, this is the y that you get. Okay? So you have to be able to fluently go between those two. So then I put this example in here because sometimes students get a little confused and they say, well, it says to use a negative 3 for x, so we put in a negative 3 in here. Well, but what is this x then? Well, keep in mind that the x is being replaced with a negative 3, but we have x in more than one spot, so that means that every x needs to be replaced with a negative 3 for this to work. So we replace all of them, and then we do 9 plus 6, that's 15, divided by negative 9, let's reduce, so divide by 3, that's 5, divide by 3, that's 3 with a negative. So if I wrote this as an ordered pair, I would get the following, so that's the x and that's the y. By the way, that does mean that this point, x, y, so 4, negative 7 is on this line. And whatever this thing is, I'm not sure how to pronounce that function. It is somehow a function. But if I were to graph this function, then the point negative 3, negative 5 over 3 would be on the graph of that function. Okay, thank you.